So we're going to do the heights in couples activity today. So you need to contact 4 couples. It does need to be a male and a female. They don't have to be married. They do need to be adults. You can use yourself. If you're not currently in a couple, you can use you and the person you are most hopeful to join to couple with. Right, it's got to, and we're not being judgmental here, but we're only looking at male-female couples. So, like my wife and I, so I am 67 inches tall, so I could do me, maybe, if I push the right button, 67, and she is 61. Then you fill out the information for 3 couples. Okay, and then you need to go on the wall and measure your height, and then go give the wall a big hug and measure your wingspan. So my height is 67, and my wingspan, I'm just going to guess, I got little stubby arms, 66. Okay, then I've sent you an email, and you need to go in and plug all those into the email and send it, and then I will put all the information up on the board. So pause the video, take care of that. Welcome back. So, let's find, here are the heights. So, you need to go into your stat, and all of these will go in L1. But they have to be in the same line as the female partner in that couple. So your first entry needs to be 7160. What I recommend you do is enter all of these into L1, and then enter all of these into L2, and then below that, enter all of these in L1, and then enter all of these in L2, and that kind of gives you a way to check to see if you have the same number of entries. Now, you're probably going to make a mistake, and we're not really concerned about that at the moment. So get all of those, put in your calculator, and then come back, pause the video, and come back. And here are my entries. Okay, and just to be clear, 68. So I had 17 entries emailed to me. And each of you did 4. 17 times 4 is 68. So you should have 68 entries. If you don't worry about it. It's okay. Your number will be off a little bit, but that's not what's important right now. Okay, what do we do with this? Well, on your worksheet, it says, maybe, if I can find the rest of mine. What would you guess the R value to be? Well, we need to look at the graph. So everybody push second y equals, and we get into the stat plots. So second y equals. Now, there are 3 plots, and it doesn't matter which one you use. The default is to use L1 as your x's and L2 as your y values. So if I hit enter on plot 1, it asks me all sorts of questions. What kind of graph do you want? Do you want to draw a histogram, box and whisker? Do you want to connect the dots? Do you want to do steps? We want dots. Don't worry about it. So I want to turn on the plot, and I want to make sure it's on scatter plot, so the dots that are not connected. And then my x's will be L1 and your y's will be L2, or whatever it was you used. And then down here, it asks me, what do you want the marks to look like? Do you want them to be boxes, or plus signs, or big dots, or small dots? I'm going to pick big dots, because we don't have a ton of points. Okay, whatever you have, it's not really going to matter. Okay? So, Everybody push y equals. And if you have an equation in your calculator, clear it out. And notice above y equals, my plot 1 is now highlighted. So you can turn your scatter plot on and off right here by just clicking plot 1, turning it on and off. So you don't have to go in every time and set up that plot 1. It's defaulted at x is L1 and y is L2. Yeah. Okay. Oh, where are you stuck?
I can't see the pictures very well, and I can't tell which one you want me to go to, because there's that one with dots, and there's
No.
that one with dots.
No, that's steps. You want this one, yeah.
I want that one.
And then whatever you, okay, so push. Now everybody push graph. Okay, if yours says error, go back into your stat and go down and make sure your two lists are the same length.
With the y equals, what do I do then?
Yours are not the same? Well, just throw in a number then. Throw in a number. Go up from the up, 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 up. There you go. Yeah, just put in a number. Okay. Who else has problems? Anybody else having trouble? Okay. Okay. Does anybody see any dots? So, are you still getting errors? Well, there might be more problems. Yeah, that's a problem. Okay. Anybody else getting errors? Nope. Just push graph. Yeah, right there. Okay. So everyone look up here. Why don't I see any points? My window's way off. My window goes from -10 to 10 and from -20 to, or from -10 to maybe 20. So everybody push window. How big should we make our X's? What was the shortest male? 60 something. So let's do 60. What was our tallest male? 78. So let's do 80. Because we want to be smaller than the smallest and bigger than the biggest. And then what should we count by? 1 is probably okay. Because your calculator can only have about 20 dots. If you have more than 20 on either axis, it gets kind of tight. So this would be a window of 14. So that's fine. So we'll count by ones. Shortest female. Were there any 50s? 59. So let's do 57. Tallest female. So let's do 75. And then I push graph. So do you notice how I have a dot on the far left of the screen? Did you do negative? You did -60. Who's having trouble? So I'm going to change my X. I have an X that's kind of at the edge of the screen. So I'm going to do 62. There we go. Now it looks like I captured everyone. Well, yeah, just make it fit. Oh, okay. Okay, anybody else having graph problems? Well, yeah, if you had to force a number in, then it's going to look a little bit different. Okay, so the next question. So anyway, does it look like there's a pattern? A little bit. Is the pattern positive or negative? So something like that, right? So we would say that our R value is positive. Would the R value be high or would it be low? Pretty low. So what do you want to guess? Positive 0.2 or 0.4, something like that. So you need to draw the scatter plot. Now, nobody wants to draw the dots. So all you do is draw the cloud. Okay? Because that tells us pretty much what we want to know. So somewhere on that page where you got room, draw an X and Y axis. And what did we do? 62 to 80, and then 57 to 75, something like that. And then I ended up with the cloud that looks kind of like that. Okay. Well, we can ask the calculator what the R value is. And some of you are going to end up with a different R value because you didn't quite get all the points in right, or maybe I didn't. I don't know. So push stat calc, and we want to do number 4, linear regression. And go down to calculate. And I get an R value of 0.17. What is yours? Okay, so you guys need to turn your diagnostics on. So if you don't have an R value, watch this. Push second 0, which is catalog, and find the letter D. Where is D? It's this one, X to the -1. And then scroll down until you find diagnostics. And then enter on diagnostics on, and then hit enter. And for some reason, that turns the R value on. I don't know why you would ever want the R value to be off, but the default on the calculators is to have the R value off. Do you need help? Okay. And then you can redo that linear regression. And the R value is 0.17. Okay, so here's a question. Do shorter guys couple with shorter girls? Yes. How do we know? It's positive. R is positive. Can we accurately predict a boy's girlfriend given his height? No. The tall boys kind of date taller girls or marry taller girls, and the short guys marry short girls, but the prediction is bad. What is it about this number that tells us the prediction is bad? This value is a long way from 1. Oh my goodness, come on. It's not my day. There we go. That number is a long way from 1. So the fact that it's positive means that as x gets bigger, y tends to get bigger. But because it's so close to 0, it's not a very good prediction. Okay, there is that cloud does go up to the right, but the cloud is kind of close to a circle. It's not very predictive. Okay? So, calculate the point of averages. So remember, there's a line that goes through the middle of this, and the very center of that is x average, comma, y average. How are we going to calculate that? Well, we go into stat, go to calculate, and we want to do a one variable statistic on L1 and then do a one variable statistic on L2. So one variable statistic. Now, if you have the old calculator, here's what you need to do. So you get this, one variable stat, right? So if you want to do anything other than L1, the buttons are the number buttons. One is where's that? One is L1. So what you do is second L1 or second L2, and then when you hit enter, it will give you the one you want. So we need to do L1 first, write down the average and the standard deviation. Sigma. So the top one is average, so 71.35, and standard deviation is 2.599. I should probably write those down. So why am I struggling with this today? So 71.35 and plus or minus 2.6. And then we do the same thing with L2. So we push stat, calc, one variable statistic, and then we want to change it to L2. And I get, oh shoot, what was it? 64.5. Well, whatever. Okay. So, this point right here is 71.35, comma 64.5. Who is at that position? Well, probably nobody, but if they existed, what can you tell me about those people? The male is the average of the males, and the girl is the average of the women. Okay, so they are as average as it gets. Okay, so that point is called the point of averages. Okay, the SDX is 2.6 and the SDY is 2.9. That's interesting. The males are less spread out than the females. That surprises me. I wouldn't suspect. They're usually the same, but because males are a little bit taller, they're usually spread out a little bit more. Okay? Yeah. So, the line I have drawn is called the SD line. The slope of the SD line is the SDY divided by the SDX. So what is 2.9 divided by 2.6? What do you get? What does that mean? That's the slope. What does the slope mean in this case? Okay. So the slope of the line is 1.1 over 1, which means for our predictions, every time a woman is 1.1 inches taller than average, then her couple partner should be 1 inch taller than average. Does that make sense? So anybody that lands on this line would have what characteristic? And are they all going to be 1.1s? No. So if you're on the line, what do you know? No. Not average. Your z-score and the z-score of your couple partner is the same. We got 2 non-mass squares today. It's okay. First 2 are free. So if I look at the graph and my z-score is -1, that means I am 1 standard deviation below average of the males. If my wife is on, if we are on that SD line, then she is also 1 standard deviation below average in reference to the females. Does that make sense? Okay, so if you're not on the line, that means one of you has a higher z-score than the other. Does that make sense? So if you're not, if you're a, what do you know about these people? The z-score of the girls' z-scores are higher than the male z-scores, right? And below, the women's z-score is lower than the male z-score. Okay? All right. Let's look at, this one will be shorter to do. So, would you say it's a good idea to predict a woman's height using the height of her partner? No, not a good idea. Is it better than randomly guessing? Yes, but it's not a good idea. All right, so let's go over here. Huh. Okay. Here are the heights and wingspans for our class. So go into your L1 and clear it out in your L2. Let's put height as L1 and wingspan as L2. Stat. L1 and L2. Height is L1. Wingspan is L2. Yeah, we're done with the other list. Yep, all that time you spent was wasted. Oh, I messed it up. Yeah. So I have them all entered. Do we need to change our window?
Yeah, you need to change the Y window because it's.
So if I push graph, oh, I lost my window. So what was it? It was like 64 to 80, 57 to 75. So if I graph that,
Change that one to 80 though because Randy was 79 wingspan.
I gotta turn my scatter plot on, and I graph it. Yeah. So you go to y equals and just highlight the plot you want. Okay, so let's change my, I'll put my x max and my x minimum is 60, and then we need to change the y values to what? 80, because we have an ape in the class. Okay. So draw the scatter plot, and remember all you have to do is label your x, your x's, your y's, and then draw the cloud. Okay. What would you guess the r value to be? That's a pretty good frisbee. I'd say 0.8, 0.9, somewhere in there. Is Randy going to throw everything off? He's not going to throw the r value off because he's in line. He is going to affect the standard deviation and the average. Okay. Should we get rid of him? Teachers have been asking that question since kindergarten. Okay. So we need to calculate the r value, stat, calc, and then go down to linear regression. Wow. My diagnostics broke. Okay, diagnostics on. I told you never have to do this again, but my calculator tried to update and I stopped it and it broke everything. All right, so uh-oh. My R value says 0.08. That can't be right.
Yeah, I got 0.95 as well.
Ah. So why might my number be so off? What does 0.85 mean? 0.085 means something is seriously messed up. So I must have one point that's way off. Let's look at my
Oh, hey, by the way.
So this should be 65 and oh. How about 65? And then this one, well, look through it. Well, it's got to be way off. You should be able to just look and oh geez, I did. Yeah. Okay. Now I'll do my one variable stat or my linear regression 0.95. Okay, so does wingspan increase with height? Yes. How can you tell? It's positive. Okay. Can we accurately predict somebody's wingspan using their height? Yes. How do we know that? We are really close to 1. In fact, 0.95 is very, very predictive. You don't see numbers higher than that very often. So height is a very good predictor of wingspan, and the other way around. But if we know somebody's height, do we know their wingspan? Not exactly, but we can get close. Okay, so we need to calculate the point of averages, which means we go to one variable stat, and the average height is 67.67, and the standard deviation is 3.9. Okay. Then we do the same thing with 3.9. We do one variable stat, but with L2. And the average wingspan is 67.7 with the standard deviation of 4.3. Okay. So my point of averages is 67.7, 67.7. Okay? If you are that person, what quality do you have? You have average height and average wingspan. Does anybody fill that position? Not in this class. How do we know? We didn't use decimals. We rounded to the nearest inch, or half inch in one of your cases. One of you was vain, and you needed a half inch, apparently. Okay. What is the slope of the SD line? It's going to be 4.3 divided by 3.9. Which is 1.1. That's interesting. That's what it was last time. Which suggests when your wingspan gets 1.1 inches longer, you get about an inch taller. Now, it turns out that the SD line is actually not a very good prediction. Yeah, it's off by a little bit. It's close if you're near the averages, but the further away you get from the averages, the further off it's going to be. So there are actually two other lines. There's another line that does a really good job predicting wingspan from height, and then there's a third line that does a good job predicting height from wingspan. They're not the same thing, which seems a little funny, right? If I use an equation that uses your height to predict your wingspan, shouldn't you just be able to use that equation backwards to predict your wingspan or your height, or other way around? Yeah. Okay, was that it for this worksheet? Okay.